Good morning, Accelerate. Today I'm going to be talking about developer tooling, and specifically tooling for indexing that we've been building. Just for a bit of background, we are a dev shop on Solana, and so for the last 2 years, a lot of our day-to-day has been building and shipping indexers for our clients. And so we realized that when you look at the three main components of indexing, which are decoding the data, sourcing it, and processing it, a lot of the code has to be rewritten, and it is actually pretty trivial to encapsulate it into a framework. So that's why 8 months ago, we started Carbon, a modular Rust framework for indexing Solana data. And so our premise was simple, and I think everyone has experienced this. As an app dev, you just want your accounts in a database. I want to plug in my RPC, WebSocket, gRPC, whatever source of data. I want to plug in my IDL, and simply be outputted clean Postgres tables with all of my accounts. And so we don't want to be spending time rewriting the same pieces of code over and over again. And at the end of the day, that's what developer tooling is for. We want devs to focus on delivering value to their users, not on rewriting everything over and over again. So let's get right into Carbon. So as I mentioned, Carbon is an indexing framework on Solana. So it basically helps you source, decode, and process the account and instruction data from your program. So let's get into each part. But what's important to understand is that each of the data source, decoder, and processor are traits. That means anyone can publish their own data source, decoder, or processor for someone to reuse and just publish it as a trait. So first, data sources is essentially a struct that can be consumed for account or instruction updates. And as you can see here, you have this trait that you can implement. But as I mentioned, we don't want to be rewriting the same old pieces of code again and again. And that's why we have published today 7 data sources crates that can be plugged into Carbon directly. So we have multiple for RPC and WebSocket methods, such as program subscribe, block subscribe. We support Helios enhanced WebSockets, Yellowstone gRPC, and Shred Stream gRPC was contributed recently. So that means you're not vendor locked in, and it's a one-line diff in your code to change where you're sourcing your account or instruction updates from. Once you've sourced your data, you need to decode it. And you also have 2 traits here that you can implement, but same thing as the data sources. It's not something that most devs should be doing. What you should be doing is either using one of the 40 decoders that we have already published, or if you have a custom program, you cannot expect us to already have published a crate. So you can use our CLI and generate from any Kodama or Encore IDL a decoder code for Carbon. So that means you can choose your data source, use the CLI, generate your decoder, and you're already good to go with a stream of account and instruction updates that's going to get right into your processor. So the processor is the custom logic side of things. You typically want to do things like sending to Kafka or storing accounts on Postgres or activities on Postgres, or you could trigger an event based on something that you've seen happen on chain. So this is up to the devs. Yeah, it's up to the devs. And then you just put everything together. You have a nice builder pattern. You choose the data source. You choose your instruction pipe. And you can put the decoder and processors together there. You can do the same with accounts. So now we're going to do a quick video demo. So it's not a live demo, it's a video. It's an example that actually requires less than 150 lines of code. And it runs a SPL token program account index using real-time updates. So it doesn't go and fetch the current state of the chain. It indexes from nothing in the tables, and it upserts accounts. So here we use the Helios laser stream as like a data source. So it essentially uses Yellowstone gRPC behind. I'm not going to go over all this code, otherwise I'm going to go over time. But there are like 4 parts. Essentially here we start our Postgres client and GraphQL server. Then we set up our Helios laser stream data source. Then we build our processor that's simply going to save token accounts and mint accounts to a DB and do some metrics so we can see how things are happening in the logs. And finally, we put everything in our pipeline. So here, every 10 seconds, will be logged the current status of the indexer, and we'll get updates from LaserStream, and it will be all indexed inside our Postgres. So let's look at the video now. So here, as you can see, we have nothing in the DB at the beginning. And so we're going to run our example. By the way, this example is available in our repo in the examples folder. So we're going to have to wait 10 seconds for the first metrics flush to happen so that we can see the status. And here, as you can see, we've had 26,000 Yellowstone updates received, and a bunch of writes happened to Postgres. So here, we now have 750 token accounts and 212 mint accounts in our DB. What we're going to do is get one of the mint accounts that was stored and look at the on-chain data and compare it to what our GraphQL server returns to us. So here in the DB, we store all the pub keys as 32 bytes, so that's why there is some decoding happening. OK, so this is a pump token. We're going to go on Explorer. As you can see, it has a bit less than a billion supply and 6 decimals. And here, we can see on our GraphQL server that everything has been properly indexed. We have the same supply, same decimals. We can see also that token accounts have been indexed if we run this query. And now let's look at what has happened over 1 minute and 30 seconds. And we can see that we have not fallen behind. We have done a lot of saves on the token accounts and mint accounts. And yeah, here we go. So what's important to understand is that here, there is some piece of code that had to be written outside of the 150 lines, which is the actual implementation for the GraphQL schema and Postgres tables schemas. And so this is the next big thing that we're working on right now. We're essentially building a Kodama renderer that's going to support any Kodama IDL, so Anchor, Shank, and Kodama itself. And it's essentially going to first generate your Rust decoder the same as our current CLI was doing it. But optionally, it's also going to be generating your Postgres schema and GraphQL schema, meaning you'll basically have your whole program's real layer generated from one IDL and data source choice with our CLI. Additionally, we have other roadmap items that we're working on. So, of course, we need to get a documentation website up. That's important. We are currently doing a lot of testing on all the decoders that we have added with fixtures. We have put a lot of emphasis in our data sources on real time. But a big thing that we are working on is adding historical data sources so that the current state can be backfilled. And lastly, we want to add validator account snapshot support as a data source to be able to have initial account state when running the indexer. So we recently crossed 300 stars on GitHub. And of course, while the metrics feels nice, it doesn't really push the needle. The pull requests do. So if the talk sparked an interest, an annoyance, or an idea, don't hesitate to open an issue. A PR will be answering very quickly, and we're always looking for contributors. Or if you'd rather just talk about indexing or anything related to the read layer on Solana, I'd be glad to talk on Telegram. Thanks for listening.